Hello, it's Duncan. Our bowling simulator experiment using type-driven design is feature complete and quite well tested. To get there though, we've taken some shortcuts. Some code's in the wrong place and our scoring calculation is confusing and hard to test. To fix the scoring, we can analyse which parts of the code are actions and which are calculations. I'll link to a more detailed explanation in the show notes, but essentially actions are code that we can't move around because it matters when they're run. Calculations can happen anywhere at any time because they always give the same result. I found that refactoring to separate calculations from actions and reduce the number of the latter is a very powerful technique. By the end of this episode, we'll have no actions at all in our production code, and the whole of 10-pin bowling will be represented as calculations on the immutable data of game state. Okay, the test pass, and as promised, I think it's time for a tidy up. First obvious candidate, we identified that last week, is this roll 1 and roll 2. Our actual frames tend to have a roll 1 and roll 2, but sometimes they don't. An in-progress frame will only have a roll 1, an unplayed frame will have no rolls at all. I think we originally had a nullable roll 1 and roll 2 in our frame, that's up here. We changed that because we weren't using roll 1 and roll 2 much. But now that we are, we've ended up with roll 1 and roll 2 as extension functions that resolve to either the roll 1 and roll 2 that actually are properties or null. That's just unnecessary complication, really, I think. So what I think we'll do is we'll go to frames and we'll say that we will add into frame the fact that it can have a property of roll 1, which is a pin count, but that pin count may be null if that particular frame doesn't have that roll. And also we'll do the same for roll 2. Note that that makes these extension properties unused, because where we are talking to roll 1 and roll 2, we will talk to the actual method now. So we might as well just delete these and then fix up the compile errors over here. So what are they? Well, unplayed frame is not abstract and doesn't define roll 1. Well, we can either define roll 1 to be null in an unplayed frame, and same with roll 2, or we can say that by default a frame has no roll 1 or roll 2. Now, we can't do what I've just typed because the interface can't have fields, but we could change this to be a computed property. That's a getter, and in both cases, if you call the getter, we will just return null. So that fixes unplayed frame and unplayed final frame because they'll default to null, which is what we want. What's the next issue? Well, in progress frame has a roll, but it doesn't declare that it overrides the one that exists. That's easy enough, and we'll take the opportunity to just lay that out a little more vertically. Next issue, roll 1 in progress final frame needs to say that it overrides, as do these two. Any more? A strike? Yes. Normal completed frame? Yes. Normal completed final frame? Wow, this is quite easy. There we go. So the question is, does it pass the tests? Well, that's pleasing. And note that a bonus completed final frame has a roll 3. We hadn't had to add an extension for roll 3, and that is because if we look where this is used, it's used in its own total pin count and just where we render it here. So on the whole, that's quite a bit simpler, and I think worth checking in with extract roll 1 and roll 2 frame. Maybe even pull up. Good. I'm going to leave this frame total pin count for now and look at these two scorecards with their implicit cast to any. First of all, why do we have an implicit cast to any? And I think the answer is that this expression here, in fact we'll find out if we delete that, you can see what it's saying is that this if resolves to string here and pin count here. Now we could solve the problem by saying roll 2 to string, and that way both branches of the if would be string. But it seems we've got a lot of duplication here, we keep on doing it. So let's see if we can solve our problem a better way. What I think we'll do is we will pull this expression here into a method. Well, actually an extension. And I'll leave it called any for now. Now the problem is in this function, and we could solve it here by just saying dot value. Now we'd like to use this function here in all these other places, but the problem is it relies on isSpare, and isSpare is in normal completed frame, there it is, but it's not part of our interface because whether a frame is a spare, well, it applies to completed frames, but it also, I think, applies to the in progress bonus final frame. There you are, there. So we don't really have an interface that we can hang isSpare on, but what we could do is we could pull this isSpare out as a parameter and call it isSpare there. Now IntelliJ has messed that refactor up for reasons, so let's get rid of that. And having done that, we'd further like to be able to use this, whatever it is, I think maybe it is /if isSpare. We'd like to be able to use that for any frame. So we'd be able to say frame./if, and that way we'd be able to use it in here and here and here and so on. The problem is that in frame, roll 2 may be null. We've moved it up here into frame, but it may still be null. And we don't want this to work on any frame that does have a null roll 2 because they couldn't actually be isSpare. Does that make sense? I think so. But what we can do instead, take that back to normal completed frame, we can make this roll 2 into parameter. And now we can make this pin count into our receiver, like that. And now this doesn't depend on frame at all. So it means that we can use it in here, for example, because we know normal completed frame does have a roll 2 and can evaluate isSpare. So we can put that in there, getting rid, as you see, of implicit class to any, and in there, and in there. So now that can go, and that can go. Check it all compiles and runs, which it doesn't. Interesting. I messed that up. What we're getting here is we're getting a 10 here for a second strike. I think what we should really be doing is this dot toString. That way we'll be getting the toString on pin count, which will do the 10 to the x. Yes, that's better. And does pass. Good. And now these are all quite a bit simpler. I think maybe we can just inline them. So we'll do that one, and that one, and that one, and that one. And now we can see the form of a scorecard for each of our frames and see that maybe we'd like to pull strike up, I guess, to there. Just looks a bit more pleasing, doesn't it? Run. Good. Take that out of there. And I think if we made this into a when, we could pull that up there, and that would look quite neat. Commit that with improve frame to scorecard. Okay, the next thing I want to look at is list of frame to scorecard. This sort of grew this way. It passes the test, but it's hard to see how it works. In particular, one of the problems is that we have this score here, and we're adding into it in lots of places. So we have the frames total pin count into the score. A strike we add in the next roll and the next roll. A normal completed frame, when it's spare, we add in the next roll, and so on. It also has the problem that we're only calculating the scores when we display the scorecard. Now sometimes I'd argue that that makes it harder to test. We have to test the scorecard and the scoring at the same time. In this case, I think that our test comprehensibility is aided by the fact that we're displaying the whole scorecard every time. So I'm not all that bothered by that. But it would make for a more reusable code, at least, if the scoring was separate from the scorecard. So I think the first thing I'm going to do is separate out the scoring from rendering the scorecard. And the way I'm going to do that is, at the moment, this map indexed is returning a list of string. And that's this expression here, which is taking the score and combining it with the frame as a scorecard and then putting the score as a string in. What I propose to do is to separate this into two places. What we'll do is we will yield the score from this initial map indexed. And if we do, then this will be scores. If we look at the type of it, that's a list of score. Now what we can do is we can take those scores and zip them with our frames, which is this. If we do that, what do we have? Well, its type is a listed pair of score and frame. So now we could return the zip map. This is a score and a frame. And we can combine the two as we did here. So we can take that out of there, it was doing nothing in there then, and put that in there. Now I think this isn't compiling because we need to destructure the pair like that. But other than that, you see it does compile. Let's see whether it works. Oh, good. So that means we have separated out the scoring from the rendering, and we could take this thing and extract that to a function, which is 2 scores. And now if we inline this and this is a single expression. And so our scoreboard is take the scores, zip them with the frame, and then combine those together to get a scorecard. And I wonder whether that might be slightly clearer the other way around. So we'd say zip this with the scores. That would make this a frame and the score, and still pass the tests. Good. And IntelliJ isn't IntelliJ enough to recognize it, but I think there actually is a version of zip that takes a transform. So in fact, we could say we can get rid of that bit, and then we don't need to destructure. Blended. And then we've separated the scores from the rendering of the scorecard. I think we might reasonably make this a top-level function and move the bits that are just about the scorecard into another file. Let's say we want not to scorecard, but rendering. What should go in there? Well, we've got game to scorecard, line to scorecard, list of frame to scorecard. Scores should stay here. Frame scorecard should move. Slashes is part of the rendering. And our total pin count, that's as part of our 2 scores, so that should stay here. Going to put that with a lowercase s. Oh, did I change that? Don't think I did. Let's go back to rendering.kt, refactor, and add. So now scoring has list of frame to scores and has a helper of total pin count, and we have a rendering that has all the details of formatting like this. That feels like a good change, so we'll commit it as separate scoring from rendering. Right then, back in list of frame to scores, I think we still have some issues here around how easy it is to understand. And I often find that separating actions from calculations helps in these sort of areas. Now, actions are things that matter when and where they happen. So when we're adding to the score here and here and here and here, those are all actions. But these other things here are calculations about actions. We can often make things clearer by doing a calculation and then a single action. What do I mean by that? Well, let's have a look in here. For example, we can make a single action in this strike place by saying that we have a var, which is bonus score, which starts off at a score of 0. And we could add to the bonus score here and here, and then we can add the bonus score into the score. So there's only one action. Is that the same? Yes, it is. And now we'll try and make this bit look the same. So here we'll say we've got var bonus score is 0. And then we'll say bonus score plus the next roll. And then we'll say score plus equals bonus score here. So that works exactly the same as well. Now that we're only sometimes adding in the bonus score, what if we always did? So what if we had else in here? In which case we would say score plus equals the bonus score of 0. Well, that's going to work out the same. Yep. But now we can lift this score plus equals bonus score, this bit, out of this when. So we can turn our when from a statement to an expression. So we can say val bonus score is, well, it's this thing in this case, it's this thing in this case, and it's score of 0 in this case. And now we can do the addition in one place. So we can say score plus equals bonus score and run that. Okay. And now we've got the action of adding to the score here and here, but actually we could just do that in one place. So this would be score is the bonus score plus the frame total pin count. That's there. Still good. Now, in a sense, all we've done is kicked this action can inside strike and here, but we could do better. If we move this bit up here, you can see that we actually set bonus score to be score here, and then we only add in next roll if next roll is not null, and then we return bonus score. So I think we could just say that the result of this expression should be, if the next roll is not null, then it's next roll, else it's score 0. Then bonus score could go away. That has failed, and it's failed I think because this next roll is not a score, so we need to build a score of next roll's value just to make those types work. There we go. Now what we can do is we can lift this score bit out. So if we take the score there and wrap that into that, and then put else in there, that should be the same expression. And it is. And now IntelliJ is telling us that this could be an Elvis. Nice. Let's see if we can do the same sort of thing in Strike. If something's a calculation, we can always move it around. So this next roll, for example, we're doing in here, but we can actually calculate it here if we wanted to. If we run that, it's the same. Now, if we bring this bonus score down here, if bonus score starts at 0, then here, once we've added next roll in, well, you can see we could in fact just assign to bonus score. We could say bonus score here is the score of the next roll's value. Is that true? Yes. And now let's look at rewriting this expression. So I'm going to call it val bonus score 2. And I'm going to say that that is when. Now, when next roll is not null and next roll is not null, then we've added in the score of next roll value and the next roll's value. So we should be able to say when next roll is not equal to null and next roll is not equal to null, then the bonus is the next roll plus the next roll. When the next roll is not equal to null and the next roll is equal to null, then we have a score of just the next roll, and we have to get its value. And I typed that badly, that's next roll. And if they're both null, bearing in mind that next roll can't be null and next roll isn't null, then our bonus is a score of 0. Now that compiles. If we're not using it, we won't have broken anything. But I think that this thing has the same value as this thing. So let's return bonusScore 2. Test still pass. And now we can get rid of this altogether. And inline that. And run. So the effect of all this has been that this here is entirely a calculation, and the action only happens here. That makes everything a lot easier to reason with, and in fact we might well want to take this thing out into its own method. So let's extract that. But you see, this is a problem. This has to be a method on list of frame, because it has to go and get the next frame here and the next one here. It's not very satisfactory. What we'd actually like to be able to do is ask an individual frame for its score. So let's undo that. And instead what I'm going to do is I'm going to pull this next frame out of this when. So let's move that up there. And next frame is used there, but also it could be used here. So let's just make this next frame. There's a problem though, and that is that in the case of strike and normal completed frame, we knew there always would be a next frame. We don't know that for every frame. In particular, the final frames won't have a next frame, and so this will fail if we run it. There we go. We can solve that problem with get or null. So we can say replace that with get, change it to get or null, and now we have some issues here. The next roll is next frame roll 1, but in fact we can just put the question mark in there because this is always nullable anyway, and the same is true there. Is that true? Why, yes it is. Okay, I'm going to do the same thing with this expression here. So we're going to make a variable out of that, which is next frame, and move that up to the top level as well. And things are still okay. And now all the indexing is moved out of here, we can take this thing and extract a method, which is bonusScore. Now you can see that that relies on a nullable next frame and a nullable next frame. That's fine. And it says, is the frame a strike or a normal completed frame, and so on. We can make this better if we make this the receiver. Run to check that's still true. And it is. I think we can just tighten that up. And now go back up to our frame to scores and see what we can do with that. Okay, at the moment we use this map indexed in order to get the frame and the next frame and the next frame. There's another way we could do that, and that would be to say we would take this windowed, and windows run the little window across our list. So we want the size of that window to be 3 frames. Our current frame, the next, and the next. We want a step of 1, so that every frame becomes a first frame. And we want partial windows is true, so that we see the last couple of windows. Now, what's the type of that? Let's ask, and it is a list of frame. If we take our windowed and we map, then it in here will be a window which is a list of frame. And of that window, this frame is window first, next frame get or null 1, and next frame is get or null 2. And armed with that we can calculate the bonus score like this. So we can do this in here, and that's this frame as a post-it frame. We'll run this to check that nothing blows up when we do. Well, it fails because we're adding into score more than once. So maybe if we just comment that out, things should be fine. But we don't really want to do that. What we want to do is we want to cut over to this version. So we'll comment that back in and say we can get rid of this. This is the list of scores that we want, with the issue that we need to return that. Good. And now on the actions versus calculations front, we're just left with the fact that we are updating this score every time through this map. I think we might reapply for our functional programmer's badge if we remember that there is a windowed running fold. Now that takes an initial something, and you can see in fact IntelliJ is clever enough to know that it needs to be a score. What's the initial score? Well, it's going to be 0. And then what's the operation here? Well, you can see it takes an R and a T to an R. So that's a score and a window, and we need to return a score. And this calculation we've already done here, so in fact I think we want to take these into there. Then the thing we want to yield out of this block is the running score from up above plus the bonus score plus this frame's total pin count. Is that true? Let's get rid of that. Run it. Oh, and we fail. Let's have a look. The first score is 0 instead of 9. I think it threw a RunningFold is going to include an element for the first one here, this score 0 that we've given it. So we need to drop that. Wow. Okay, that lets us get rid of that, although I think we might want to delete it altogether. Now we can inline that. This can be a single expression. It's only now actually a calculation. There's no action in it at all. At least that isn't buried inside RunningFold. And I think if we were to drop that down there, reformat, then we might inline that and that, but put the explaining names in. Splendid. I feel we're nearly done, but it's my dinner time, so I'm going to check in with remove all the actions from scoring. So I don't think now we have any variables at all, we just have calculations and can hold our functional programming heads high. So then what do we still have to do? Well, one thing, I think any extension where we're asking this is something or this is something else is a target to be converted into a method. I know whether functional programmers will disagree with me, but to my mind the Java virtual machine is based around polymorphic dispatch, and in these cases we should use it. Another irritation is these places where we're doing score of next roll value and so on. I'm not sure our conversions between score and pin count are as good as they could be. And finally, friend of the channel Yusuf points out that in the last episode we made a change here to show that we can't roll invalid pin counts. We're checking in not a final frame, but actually if we were to roll a 9 and a 2 in the final frame, well that's invalid because in the final frame, once you've knocked down 9 pins, there wouldn't be 2 more to hit. So we should fix that. And it raises the ugly spectre of whether our tests are as comprehensive as they should be. I wonder whether we could find some property-based tests that would increase our confidence. And I know that J Quick now has Kotlin support, so I'm hoping to try that out in a future episode. If you'd like to see that, then please subscribe to the channel. Please do press the like button as it helps other people find this. And you can fund this work by buying a copy of the book that I opened that price called Java to Kotlin and Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.